Farm 208, homework for week 4, Monday. So the first few ones, you guys let me know what you guys got as the answer.
None of the above.
None of the above for number 1?
Yes.
Really?
Yes.
So it's infuse, right?
There's no piggyback.
Yeah. No piggyback, good. How about number 2?
2. Instill 1 to 2 drops into each ear 3 times a day until done.
So 1 to 2 drop into each
Oh, yours is different.
ear
Oh,
as directed. Instill 1 to 2 drops into each ear 3 times a day as directed. Okay, I'll go with that. What's the verb for subcutaneous? So let's see, inject 50 units under the skin 3 times a day. AC is before meals. Inject 50 units under the skin 3 times a day. Before meals as needed. So is it 1 through 5? Deciphering?
Yes.
Alright, tablets vaginally. You're going to insert 1 tablet vaginally 12 times a day?
No.
No. So it's going to be
The last one?
none. You don't have to unwrap tablets. Only suppositories.
Oh.
So insert. The only one that works is this guy. This one sounds good, but the verb's wrong. Alright, the last one for deciphering. We're going to place how many? Under the tongue as needed for CP is chest pain. Place 1 to 2 tablets sublingually. Uh-oh. Uh-oh. Can't say sublingually.
The patient doesn't understand what sublingual.
Yeah, they may not know what that means. So place 1 to 2 tablets under the tongue as needed. No, they're missing the chest pain. So this one, suspect.
It's 4. The 4th one's a
Put.
Never
Yeah.
mind.
So we'll go with that one.
We all are so confident.
I know.
You are not the only one. There's like one variation, and we're like, no, that's the one.
I
I'm
was like,
telling
yeah,
you.
that's that one.
We know what it means.
Don't worry, it's a lot easier out in the real world. Because it's all electronic and it's written like this in front of you, like number 6, most of the time. 80 to 90% of the time. It's the 10% of the time, they'll set you apart. Alright, EDS, a pounds dispense. L is how many?
50.
Go with the max. 1 or 2 is the max.
2.
3 doses or 2 doses? 3 doses, right? So 2 doses, 3 times a day, that is 6. And make sure you round down. How many days would that last? 8 days, round down. Creams, just like mLs, we're going to approximate about 30 grams per ounce. So 2 ounces would be about 60 grams. And for us, we're going to assume 1 gram per dose. That's just to make our life easier here in class. So 2 ounces is 60 grams. Apply to the affected area 3 to 4 times a day. What's the most they can use in a day? 4 grams in a day. So for this one, you get a whole number. No need to round.
So wait. What?
Huh? What'd you get?
How'd you?
4 divided.
60 divided by 4. 3 to 4 times a day. Yeah. So we go with the max, with the assumption they use 1 gram per dose. Number 8. How many drops per ml? 20. So for eyes and ear drops, we're gonna approximate about 20 drops per ml. So 3 mLs would give us how many drops? 60. Alright. Let's go with drops per day. So 1 drop, how many eyes? How often? Twice a day. So 2 drops twice a day for a total of 4 drops in a day. So we'll do this one together for Wednesday's homework. It's going to open after class, so make sure you guys take a look at that before the final on Wednesday. 1 quart. How many mLs is 1 quart? 960 mLs. Very good. Teaspoon. 2 teaspoons is 10 mLs. TID is 3 times. So that's a total of 30 mLs in a day. So this would last them about 20, how much? 32 days? 10. For us, insulin comes 100 units per ml. And we're going to dispense the 10 ml per vial. Little tiny insulin vials. So in this case, we got 3 vials. That's a total of 3,000 units. Right? So it's 3 vials at 10 mLs per vial at 100 units per ml. So that's 1,000 units per vial. So 3 vials is 3,000 units of insulin. 30 units 3 times a day. How many units is that in a day? 90. So 3,000 divided by 90, round down to the nearest days.
This is what's gonna kill me. Like all these inversions and just the thousands getting to 1,000 and then I'm gonna.
So the homework for Wednesday will open up. That's exactly similar to the final, just like this one. Percentages, solutions. Make sure you are in mLs and times to percent. That will give you grams. Don't worry, all these equations will be given to you. So your units must be in mLs. Percent, let's just change it to a decimal. So 0.5 liters is 500 mLs. 20%, what is that as a decimal? 0.2, yep. 500 times 0.2. If you have the percent symbol on your calculator, I'll show you how to punch it in. Just do 500 times 20, and then you just want to push the percent symbol. Is there a percent symbol here? I don't have one. Let's go scientific. Standard? Oh, it's on your phone, yeah. If you have a percent symbol, then just multiply. How many grams do you guys get?
100.
Yeah, that should be right. 100 grams. All right, same thing. Cup is how many mLs?
480.
Almost 480. 240. 30%, 0.3. How many grams? What's 30% of 240? 72, I heard. Now we got to find the percent strength of the solution. All we do is find the fraction. The units again are grams and mLs. So that's a fraction, which gives us a decimal. And when you multiply your decimal by 100, it gives you percentage. So we've done this since week 1, fraction decimal percentages. Now let's apply it to solutions. So for 11, we got 10 grams. And the volume is 250 mLs. So that's your fraction, grams over mLs. Do not forget to multiply by 100 to get your percentage. So what percentage did you guys get? Okay, I'll go with that. So just enter the number. You don't need the percent symbol. $14. How many grams do we have?
1.5.
That's kilos. So we want grams. 150 grams. Our volume is already in mLs, so we don't have to convert those. Don't forget to multiply by 100. .3, 3 or 30%? Do you guys recall flow rate, drip rate? mLs over hour is flow rate. And then the first step is to divide by 60 minutes, then multiply by drops. That will get you to drops per minute. So for 15, let's start off with flow rate. We got 1,000 mLs per 6 hours. First step, divide by 60 minutes. Second step, multiply by the conversion factor. In this case, it is 15. Round to the nearest drop per minute. What do you guys get for 15? Do I get a second? Yeah, a second. So everyone got it? Third? Okay, good. Round to the nearest drop. 16, exact same way. But since we're using micro drip tubing, what do you guys know? Yeah, the same value. The flow rate value is the same as the drip rate value. So what do you get? How many drops per minute? Yeah, 250. The numerical value of the flow rate is the same as the drip rate when you're using micro drip tubing.
So we won't have like these formulas.
Yeah, you can put them on the board if you want.
Okay. I'm saying like during the final though.
Yeah. The class is not to memorize the formula. It's just how to apply them. Yeah, so don't worry. If there's anything you don't know, just let me know. I'll put them on the board for you during the final. All right, we got weight dependent dosing. So 3 steps. So first we got to change weight to kilos, multiply the weight by the order per day, divide by doses, and then order and supply. So let's get started. 275 divided by 2.2. How many do you guys get? 1.25 kgs. So that's going to be your starting point for B. 125. How much drug is ordered per kilogram? 25. So the patient will require how much in a day? What is that? 1,000? 3,000 even? Why didn't you say so? 3,125 milligrams in a day. But we're not going to give it to them all at once. It's going to be in 2 divided doses. Half now, half later. So 1,000. Let's round it. About 63-ish. All right. Maybe. Okay, we'll leave all the decimal point just in case. 1,562.5, just in case. The supply is 1 gram, which is 1,000 milligrams per 15 ml. How many mLs would you deliver? 1 decimal part. 23.4, you say? Dun, dun, let's punch it in. 1,562.5 divided by 1,000 times 15. Yeah, round down to 23.4. The only difference is the supply. It's in percentage. So let's follow the steps. Step A, 143 divided by 2.2 yields 65 kgs. B, 65 kgs times the order, which is, so that's going to be how many milligrams? 3250 milligrams. That's per day, but they're only going to get a third at a time. So we'll need to divide by 3. And then our supply is 2%. So 2% for us is 2 grams for every 100 mLs. So percent means per 100. And whatever number you get here, that's the same number of grams per 100 because it's percent. All right, what do you guys come up with? Huh? Who?
541.7.
You lost me, man.
54.2?
Wait, what did I do to mess that up?
Is that what you said?
No, what?
Huh? What'd you get?
I'm 1 decimal plate off. Decimal point or plate.
You're
off.
0.1?
No, I have 541.6.
0.6, oh.
So like, instead, yeah, so I'm like off.
Oh, no, you're fine. Yeah, we round to the 0.2.
541.
Yeah, you just have to round up to 54.2.
But you have 54.
I don't know where your decimal is.
I know, that's what I'm saying. I have 541.6. So instead of it being in front of the 1, it's behind the 1. So I don't know what I did.
Maybe you did 200.
1,000 mLs?
Maybe you did 200 instead of 2,000. Just double check.
So it's well, I'm sorry.
Ah, dun dun dun. All right.
My head hurts.
All right. So you need 1083 milligrams per dose. 1083. And your drug comes 2 grams per 100, which is 2,000 milligrams per 100 ml. Is that what you guys did? Sorta, kinda? So 1,083 divided by 2,000 times 100. So go back to last week's DC when we did percentages and ratios. What is 19? Ratio? No. Allegation. All right, let's do 19.
That's
and
fresh in the noggin. That's good.
okay, let's do that. Everything else should have been review. All right, allegation, type 1, because we're given a final amount. Put the order in the middle, which is 15%. We have 2 supplies, 70 and 10. Next step is to find the difference. What's the difference diagonally here? 55. And the difference here is 5. 5 parts, 55 parts. How many total parts? 60. So 5 out of 60 and 55 out of 60. And the last step is to multiply by the final volume, 3,000 mLs. Which number do they want? Do they want the top number or the bottom number? Yeah, so they're looking for 70. Here is the 70. So save yourself some time. Just punch in this one. Round to the nearest ml. How many mils do you need? 250. All right. Sounds like we got a consensus there. All right. Keep on keeping up. Let's do 20. Set up our tic-tac-toe. Type 1 allegation. We're given the final amount. 12.5 is ordered. We got 70 and 0. The difference here is 57.5. There, yeah. 50. And then this one's easy. I can do this one. 12.5. 12.5 plus 57.5 for a total of 70. And the last step is to multiply by our final volume, in this case, 250. Top number or bottom number is wanted? D70. So they want the top number. So we'll just punch in this portion. 12.5 divided by 70 times 250.
Where are you getting the 70?
Oh, you just add this. The 12 and the 57.5? No, this one, right? The denominator?
Yeah.
Add the 12.5 and the 57.5 together.
Oh.
So yeah, the right column on the right. Add those two together. That'll become your denominator.
So then how'd you get 60 for the other one?
The same thing. When you go to here, 5 plus 55, that's 60.
Sorry, I wasn't here for that explanation.
Yeah, the DC, there's the video. I posted the video. How many mLs of D70 did you guys get?
45.
To the nearest ml? 45?
Correct.
Okay. All right, the rest is just review of lecture questions. What is an NDC number? How many digits? 10. Sure, 10. 11 fields with 10 digits. HIPAA,
Confidentiality.
requires health information to be kept confidential. Okay. Requires pharmacists to provide count. No, that's OBRA. Conduct you. That's OBRA. So the best one, outside the pharmacy. That's the best one. All right. 23. Blank requires community pharmacists to offer count. I just gave you guys this one. What is it? Omnibus Budget Reconciliation Act of 1990. 24. Which of the following items should not be sent via pneumatic tubing system?
It's a tablet?
Which tablet?
The Xanax tablet?
Why not?
Because it's a tablet?
No, it's controlled. Tablets are stable.
That'll disappear.
Yeah, that one disappeared.
I don't know. I was
Got
thinking like
lost in
tubing
the tunnel
system,
with
like
the
liquids
tubes.
going through a tube. Like you
The
can't
drug
put a
nuts
tablet
got
through a tube. Like
It's the air tube
No.
for messages in the hospital. So 1 liter's too big, it'll get stuck. Even half a liter's too big. Insulin vial, looks like all of them. Don't want to send all of them. Too big, too big. Xanax is a narcotic. Insulin, if it vibrates, it'll foam up, so it's unstable. So which one should not be sent? All of them should not be sent. And lastly, are your brand and generic? Do you guys know them? These ones are easy. Pro Air. Which one's the inhaler med?
Albuterol.
There you go. Albuterol. Cialis. The end of it, the end of the drug name tells you what it does. Tadalafil. Low pressure. It lowers your blood pressure. So it is a beta blocker. Metoprolol ends in OLOL. Men don't like beta blockers. They can't get excited. Vytorin? What's Vytorin? No? Nobody got Vytorin?
You're going pretty fast for me, my friend. I have them, but
I thought you guys did your homework. You did your homework.
I
Just
did.
open it. Just open up
I
your
keep-
file.
I'm trying to keep up with you.
All right. So where are we at? Vytorin. Oh, that's a generic for Vytorin.
I don't know how you know this.
Is that amine or Simvasis?
The combo drug.
You set me up.
So that's cholesterol meds. Orencia. It's a biologic agent.
Afatisep.
Yep. Acifex, pH in the middle. Acifex, so that is an acid med. Rabiprazole. That's a protein pump inhibitor. Benacar. It's another cholesterol med. Olmesartan, all the sartan drugs like Lipitor, Provocal, Crestor. Synthroid, that one's easy. It's in the name. Throid is levothyroxine. That one's easy. And then Adderall, 1 carbon away from methamphetamine. Which is it?
Amphetamine.
Amphetamine, very good. So if your kid has attention problems, we give them speed.
They're amazing.
Yeah. Yeah, for studying too. It's highly abused in college. All right, so that is your homework for Monday. Wednesday's homework will open. That is your review